All right. So today we're talking a bit about closures and scope and maybe a little bit of hoisting and some IIFE. Uh, I'd like to get kind of like just an overall idea because I really don't know the 6.2 class that well. And I don't know anything about the 6.4 class, but like what do we know right now about closures? How familiar are we with them and what they're doing? What the point is?
Well, closures are functions that return functions, right?
Marvin, I couldn't understand any of that.
Oh yeah, sorry. I'm not sure if I hear a lot of background noise. Yeah,
Okay,
sorry.
there's some background noise from somebody else. I think I muted them.
Uh,
Go
uh,
ahead, Marvin.
Closure is a function that returns a function. Is it like that? Yeah.
Okay, yeah, that's definitely a big part of closures. She has sent a what? Okay, yeah. Closure time. It's the time for closing. Okay, so we're aware that maybe a function that returns a function is a closure. Anything else that we know about from anybody?
I know that with closures, you can have sort of private variables that cannot be accessed. They are unaccessible, but which I think is interesting.
Awesome. Okay, so there's this idea of privacy and using closures for that. Love it. Anything else that we can think about? If not, that's okay. We'll just dive into it. Okay. So there's like, I'm trying to think of like the best way to start going about it. I guess, yeah, I'm gonna share my screen and we can just kind of go through some examples and what makes some things kind of interesting. Okay, so this is the 6.4 lecture notes, which I think everybody actually has access to now. I'm just gonna go full screen. I'm gonna do this into our extras. So into the extra area, which currently has our CTA and our boundaries, same as the other day. So I'm going to make a new one, and I'm just going to call this closures. So we're just going to run this pretty much in the node environment today. And I'm going to CD into that, and I'm going to make index.js. Okay. And let's go ahead and open that. And we don't need any of that other stuff. Everybody can see my screen, I'm assuming. Let's just do a quick check to make sure everything's cool. And we'll just run that. Okay, and we get our hello Miss World misspelled. Perfect. Okay, so I'm going to write a function, and let's see how surprised we are by this function. All right, so let's say I make a function, and I say let name, and I say the name is Alejo. And I write a function. I'm going to write this for fun in ES5. So closures, it's important to say, like closures are still relevant in ES6 as well, but closures were even a bigger deal in ES5. And I'm going to get into some of the reasons around that in a little bit. But you should be aware that like ES6 has helped a lot with some things that closures solve, but it doesn't help with everything. So let's go ahead and name this just print name. It's a function, and all I'm going to do here is console log our name. Okay. And here I'm going to fire our function print name. So think about it. Look at the code. Take a second. And in the chat, tell me what we think is going to print to, or what's going to happen in our console. And go ahead and write that in the chat. Okay, we're getting some interesting replies so far. We're split. Let's keep going. Who else we got? Alejo, Henry, thank you. Doug, Amini, is that the name? Ben Salem? How do I pronounce your name? You're on mute.
Yeah, it's Amin.
Amin. Thank you. Amin. Okay, I got it. What about your last name?
Ben Salem.
Ben Salam. Oh, I was pretty close with that one. Okay. And name, okay. Fagan says undefined. We got the air from Ben Salam. Amin. I'm sorry. It's gonna take me a minute. I think you're the first Amin I've met. Okay. We got Kong says undefined. Brandon Deja. Okay, so I'm actually surprised with all these answers. That's interesting. I'm glad I didn't skip this example, right? So let's give this a run and take a look, right? So we have node index.js and Alejo prints, right? So why is this printing? Well, JavaScript is lexically scoped, right? So that means that functions are scoped to be able to see their outer scope. So when we are just looking at like this as a whole file, we are thinking about like this all has this one specific scope. So when node runs, right, we have this idea of it creates this global object. It creates an object called like this, and then it sets up memory space for variables and functions, and then it assigns variable declarations, a default value of undefined, while also playing a function declaration in memory. And I'm just going to write that out. I've previously written it out, right? So this is this idea of context, right? And this will play a part into our scope and whatnot. So when we're thinking of global execution, so when the file runs, a few things are happening. First, it creates a global object. Then it creates an object called this, right? And this is like this. I can show us this. If I just log this, right? This doesn't throw undefined. This is one of these special keywords in JavaScript. This, in this case, this is just this object. If we were to go to like, let's say the browser, let me see if I can pull up something on the browser. Okay. Right, let's just go to Google and open up our Chrome tools, right? And if I go to our browser here and I type in like this, right? For the browser, this is the window, and this is the part of its global scope. We always have access to this, right? So this is like this window, okay? In Node, we don't really have a window, but we still have this object called this, which we see here is this empty object. Browser's window, a little bit more advanced, right? Browser's this. So then we set up memory space for variables and functions. So that means this function, like this code can get run, but let's pretend I'm just writing in ES5 first. So var is an ES5, right? So before ES6, we only had var. There wasn't let and const. Now, I'm sure you've probably heard me or Leo say this before, where let and const are both block scoped, while var is function scoped. And let's kind of look a little bit what that means first. So to understand 3 here a little bit better, we're going to just do a little thing here, and I say log. Well, first I'll start with let. Okay, we'll say let. If I log name here, what's going to happen? What do we think? Go ahead and write in the chat. If I just write let and I have name, and I try to log it on line 9, what's going to happen? Rafid says you can't access it. Okay, so what's going to happen though? Something's going to happen. So I'm seeing a lot of undefineds showing up. Aranza, Crystal, Ashia, Marvin. Okay. Deja says null. Interesting. Rafid says it's not going to run because it's at the top. Yeah, but something's going to happen, Rafid. Something has to happen. Same with Ohidor. Anama says undefined. Okay, well, let's find out. Right, this will be kind of fun. Right, it throws an error. Right, I think this is kind of what Rafid and Ohidor were going for, but we actually got to say that it's a reference error because it's still running, right? It just breaks. And specifically, it says cannot access name before initialization. Now, this is because things work a little differently for ES6 and ES, like let and const, because they're block scoped, and I'm not 100% sure actually how those spaces in memory are formed. But traditionally, when we're like in ES6, if I write var, we're going to see something a little bit different. Now, I'm not going to make us guess because it would kind of defeat the point of what we just did. So, but when we do var, right, instead here we get the undefined, which is what a lot of people had answered previously. Now, this only is the case for var because of this, what happens in the part of a global execution context, which is it sets up memory space for variables and functions. So, and I wonder if I can, no, I'm not sure how to like best show this in the window or anything, but you'll have to just, there's a decent video maybe that I can share later, but essentially var, this is why people might say the word var is hoisted, because it doesn't actually move in the code, but you can think of it as more everything at var is just being declared in existence. It's like me going like this at the top of my file or the top of the function, right? There is no block scoping for var. So since this step becomes before it actually runs the code, it looks and it goes through and it goes, okay, name exists. And then there's a function called print name that exists. And then when it goes to console log it, it knows that it exists. It just doesn't know its value yet because its value doesn't come until line 11, where we're specifically saying it has this value. But it does this quick run through where it just kind of puts things into existence. And that's what's line 3 is talking about. And it defaults the values to undefined. And so that works with var, right? This is also the same with kind of like functions. So if up here, let me add a new function. Say hello. Right, if I say console.log hello world, right, and I run my, like what's going to happen if I call say hello up here? Is this going to be cool or not cool? What do we think? You can give me a thumbs up in the nonverbal feedback feature for cool or down for not cool. Or I guess yes or no. Oh, yeah, they have a thumbs up. Good. So I'm getting some cools. I'm getting some not cools. That's cool. Tight. We only have 6 people writing. 7. So we're getting a lot of cools.
Yeah, can you repeat the question again, my bad, please?
What's going to happen? Is everything going to be cool, or will there be an error thrown? All right, so I'm going to keep going. So I'm seeing a pretty good mix of things. It's about two-thirds to a third. Yeah, let's check this out. Right? What happened?
You didn't save.
Yes, thank you. I don't know what's going on here. Okay, thank you, Ashia. Right, so we get hello world. This is cool because of this step 3 where it sets up memory space for variables and functions. So it actually puts this function inside of this memory space. And this is something that's pretty interesting between let's say ES5 and ES6, right? There's a really specific difference because in ES6 we do this, right? We say const, say hello, we say this, and we do that, right? But with ES6, we're not going to get hello world. We're going to say hello world or say hello before initialization. There's a reference error, right? And this is something that's really important. In ES5, we have named functions. In ES6, no functions are ever named. Okay, you may never have thought about it like this before, and this might blow your mind a little bit. But with the advent of the fat arrow function, we are no longer naming functions. We are only creating variables, declaring variables, and assigning their value to an anonymous function. We are not naming functions, right? This is a hard thing to follow. If I say var, let's see what happens. Now var is still going to break, right? Because even though var is hoisted, it's undefined, right? So we know, because we already saw that example with our name here, and var is name, and we saw this was undefined because it wasn't actually created yet. This is the same thing. Even when we use var, even though say hello exists, if I console.log say hello, it's not going to throw an error there. We'll get undefined. That's there, right? We'll get undefined and then our error from trying to say hello. Say hello exists in the namespace at an undefined value, but it doesn't actually take on its value until here. So this is a big difference, right? If I were to, and it's something to be aware of, if I were to, I can make anonymous functions as well in ES5, right? And we can see what happens. Same thing, nothing changes. However, I could name this function, right? I could name this. I could say, hello test, right? Now, if I name this function and I call say hello, it still breaks. But I could also call hello test. And that also breaks. Thought that would work. Hello test is not defined. I guess because it doesn't, this isn't actually in the space yet. I think it hasn't picked its value. Oops, sorry. Yeah, so that still doesn't work. And that's because of the global execution contest. When it goes through and saves space for these things, it's not saving space for this yet because it's just saving space for this, and this isn't existing yet until when this runs. So it happens a little bit later. I know that's a little bit confusing, but the real point that I'm getting at is there is this difference between ES5 and ES6, right? ES5, we're able to call things up. Say I could call print name higher up, and that was all fine. ES6, I was not able to do that, okay? And replacing that is the same thing. I'm also trying to point out that we aren't actually naming functions in ES6. We're only assigning variables that value point to an anonymous function that may do something, which doesn't come up all the time, but it is something to be aware of. Okay, so let me refer to some notes. Any questions on that so far?
Yeah, so var is able to read the page and determine what's available, but not what is exactly assigned to that.
Yeah, so the idea is that var kind of hoists the variable into existence higher up. So they're a function scope. So let me show you what I mean by that too. Okay, so let's say we are making a function, right? And I say function, I'm just gonna call this var test. Okay, and this is going to be just a pretty like nothing function. It's just going to say if true. So we're definitely going into here, right? I'm going to declare testing or something to be, does this work? Okay, and if I console log here, testing, what is going, this is, and I'm not going to give the answer away. If I call var test, go ahead and think about this and write in the chat, what is going to happen? What are we going to see? I'm not, are people writing in the chat? I don't think I see it.
I think
here
we're
we go.
thinking.
I'm still thinking. Okay, yeah. It can take a minute to think. See says undefined. Very cool. Okay. Thank you, Brutus. Thank you, Crystal. Okay, everybody's jumping on the undefined train here. Crystal. Okay. Anybody feel particularly strong about their opinion? Megan, Henry. Okay. Ohidor. Okay, now we got some other people talking. Interesting. So if you feel strongly about it, talk. Tell us why. Tell us what you think and defend your point.
Okay, I would like to try.
Let's do it.
Or take a stab at it. Okay, so we have our function var test, and we're saying in the function, if true, set testing to equal does work. Now, then we have a console log testing. Now, if I'm understanding this correctly, if true is saying if var test is true, like, no, if, okay, I'm confused on the if true, but however, I believe because we're saying var test, we're setting var testing to does this work, and then we're console logging the testing as we're calling the var test, I think it's going to print does this work, because it's going to see, it's going to console log the testing, but it's also going to go back and see the if true.
Okay. Ashia, would this be any different if I had a let instead?
I think it would, because var is able, you're able to see the scope.
Okay. Interesting. Anybody
Question.
else? Yeah.
Question. Isn't the Boolean is default the initial value of a Boolean is false, right?
What do you mean the initial value of a Boolean is false?
Like by default, like if you don't.
No.
Well, you can
A
make Boolean whatever.
Boolean is just a primitive data type, which has either two states, true or false.
Yeah.
I'm just saying true. I'm guaranteeing that we go into this if statement every single time. That's all that's doing.
I'm like on the fence only because there's like part of my brain is like, okay, cool, it's maybe undefined because testing only exists within like the scope of the if statement. But being that you're using var, you know, it's sort of the thing where it exists, you know, at sort of like a higher point. Like so it's like var exists regardless. So if you're naming testing with var, then maybe it still exists. Maybe you could still console log it. So I don't really know because you're utilizing var. If it was let, then I think it would be undefined. But being that it's var, I don't know.
Okay.
Yeah, same thing for me. I'm not like too sure for var, but if it was let, we'll have a reference error.
Okay, so you're confident if it was let, we would have an error. Reference error. I like that.
Yes.
Let's start with let and just prove that to ourselves. I agree with you, right? So if we have let, we get our reference error for sure. But we are dealing with var, and that's the same with const. Constant let, same thing scope-wise. But what's the difference between var and let? What in the scoping? What's the words I even said it earlier today?
So testing will be hosted.
Yes,
Mhm.
because specifically var is function scoped. So although testing won't be available here, which I'll comment down for now because I don't want to throw an error yet, right? When I run this, we get does this work because before ES6, there was no such thing as block scope. And this was kind of a big deal. And so because of that, every time we wrote var, it's the same thing as if I would have gone var testing right there instead, and then just said this. And this makes sense to us. This, we look at this and we go, oh, okay, this exists, this gets redefined, and this has access to that because they're in the same scope. But in ES5, I mean, you could just write it like this, right? But what I had just written is synonymous to this. Now, when I console log this testing, we should see an error after, well, yeah, we're going to see an error first, right? Because testing is not defined because this testing is only in this scope. Okay, so this is something that's kind of interesting when it comes to var.
Correct. I have a question.
Mm-hmm.
What's a block? What creates a block?
Yeah, so a block you can think of as any like code that's inside. So it's pretty much starts and ends with the curly braces. It's like I'm trying to think of a cleaner way to think about it, but like an if this is a block of code, right? And if else, if I would have said else, this is its own block of code, a while loop, anything inside of a while loop, anything inside of a for loop, those are all blocks of code. They're not their own function, but they're code that will be running within their own scope. And because JavaScript is lexically scoped, they have access to seeing the variables on the outside, right? So if I were to write, here, let's duplicate this, but for, but for let test, right? If I really wanted let testing to do this, right? If I wanted this to work, I would have to lift up testing, essentially. Right? And that's maybe something we're familiar with. And that's something that let me just comment this out and say let, right? And that,
Do you have to take the let from 35, line 35, when you do that?
do I have to take the let?
Before testing on line 35, when you already...
Good question. So let's see what happens. So I really like that question because look, when I run this, I get undefined. So this is annoying, and it's exactly because of what Ashia is talking about. So I have on this scope, this of this outside here, from here to here, I have created a variable called testing. Now I've entered an if block, and inside of here, I've actually created another variable inside this scope called testing, right? And so this is true to its scope, right? So, because I could console log here, testing, and we'll see I get does this work and undefined, but because this testing is still referring to this outside scope. I essentially created another variable. So every time you're in a scope and you call for a variable, it looks first at the variable names within its own scope, its own little context. If it doesn't find it, then it will start to go up towards its parent. So what do I mean by that? Well, let's just reassign the value of testing instead. Instead of actually declaring a new variable, since it's not being declared, it's going to look at its next testing variable and it will see, oh, there was one on this scope, and now this one will be updated. So it's a little bit different. A little confusing. I know, it's like kind of like mind trip, but there's some oddities with JavaScript. But the more comfortable you get with this, the more obvious it will seem, even though that's kind of obvious that I would say that. Any questions on this part? Okay, so let's keep going with another example. All right, and I know people are like, I thought I was signing up for closures, not a varlet seminar, right? It's going to relate back, I promise. Okay, so I'm gonna write another little fun one. And I know my class has seen me write this before, but let's say I write a function, and I'm just gonna call this print2 5. Okay, and all this is gonna do, let's see if it's gonna do it for me. How do I get this? I don't like it. Okay, let's say I say var, and I say I is equal to 1, while I is less than 5. I'll say I plus plus, and I console log I. Okay. And here I'm going to call print2 5. Anyone want to tell me what they're expecting to see?
1, 2, 3, 4.
Okay, I like that. 1, 2, 3, 4. Very fair expectation, and you got it right on the money. All right? Makes sense. I don't need to explain this. Fantastic. Let's continue. I'm going to make a set timeout. Set timeout, as you're aware of, takes in a callback function as well as a time period for how long we want something to wait before firing that callback function. So those are the two main arguments. There also isn't more arguments, but I don't want to go into those right now. We can go, I'm going to console log inside of our set timeout. I'm just going to say I want it to wait a second. Whoops, that's a millisecond, right? How about now? In the chat, think about this. And it's okay if you think you don't need to think about it because it's obvious. Go ahead in the chat and tell me what will print. Okay, thanks, Amin. Thank you, Jonathan. Okay, Marvin, Crystal, Kong. Oh, Alejo, interesting. Henry, Rafid. Alejo, you're like a salmon going against the grain. Wong, okay. So I'm essentially seeing just a bunch of renditions of 1, 2, 3, 4, either forwards or backwards. And Amin, you just think the number 4 is printing one time. Is that correct? Okay, cool. All right, let's try this out. I like this. Why is this not clearing my console? There we go. Okay. So we wait a second, and then we get the number 5 printed out 4 times. What? Oh, no. All right. So this is a good gotcha in JavaScript, and this actually can come up in coding interviews because this is I mean, I haven't had it happen to me before, but I've seen everything I've ever read on what to expect and study for talks about this problem. It's quite a famous problem in JavaScript, right? Nice, because it happens at 1,000, right? So I think Deja's getting it, which is awesome, right? So the idea here is var, we've already decided, is function scoped, right? So var is, this is the same as me writing var I, and then writing I, right? So just a way to visualize it. And so what happens is we go through the first iteration, and this gets passed in to be resolved somewhere else, right? We'll call it the browser API. That's part of the event loop. In this case, it's the node environment V8 runtime engine, whatever. And then Alejo's nodding. Maybe I got it right. And then we have I is 2, I is 3, I is 4. Eventually, I hits 5 because that's actually what stops the loop from running, right? So that's when it terminates. And so then whenever this resolves, we end up looking at I. And so this is keeping a reference to I, right? So there's, you're gonna hear me start using the word reference a bit. So like, it's not keeping its own individual instance of I that occurred at this point in time when it first was called. Instead, it's actually keeping a reference to this variable from within inside its scope. And so after the loop has finished running, I is going to be 5, right? Because the loop has stopped running. So when it goes to read what I is, it ends up reading that I is 5 and it prints it 4 times. So now there's obviously a kind of a new, this is ES6 new, it's not new for us, but like, right, this is a boring solution. If I write I is 1 here, we get the behavior that we're all expecting and used to seeing so much. And this is a great addition to ES5 and to ES5, which is now, you know, ES6. This is a great thing because this clears up a lot of mistakes, right? This is one of the good arguments for like, hey, this is why you should be using let, because with var, you get some weird behavior. But let's pretend we live in a world where there's only var. This is a world that was only like so many years ago, right? Whatever that year was, 2015, right? Like there was a time not too long ago when this was all there was. So how do we fix this, right? How do we get this to work? And this is where closures can start to play a part. So talking about, let's see, how do I go about doing this? So let's say instead, before I talk, so just hang on to this thought, and we're going to talk about a couple things first. Okay.
Corey,
Yes.
so you mean how to get it to work, how to get it to print 1 through 4 using var, right?
That's correct.
Okay.
That's going to be the goal.
I guess we declare a variable before set timeout. We set it to I, and then we.
Okay, let's try that. So you want to set a variable here? We can say like var j equal to I. Is that what you're thinking? And then console log
and then
j.
you call it with j.
Okay, let's try it. I like this. Nope. So that's not going to work because we only have var. And so with var, which is function scoped, we've just hoisted I also to the top. We've also hoisted j, I'm sorry, which directly references I and gets reassigned with every iteration. And at the end, we go to print j, which is already all 4. So that doesn't quite work. I like where your mind's at, though. I think that's a great step. So let's hang on to this. Okay, let's hang on to this for a minute. Can anybody tell me what IIFE stands for? Any acronym? Can anybody tell me what IIFE stands for? What is this an acronym for? Hint. The hint is that it's an acronym. Oh, Dora, I'm going to tell you the answer in like 2 minutes. There's no need for a hint.
Immediately invoked function expression.
Somebody looked it up. Thank you, Henry. Did you know that or you looked it up?
Shout outs to Google.
I know. It sounded like you were reading. Immediately invoked. I like it though. function expression, right? This is commonly referred to as IIFE. Don't forget that. This is a common word in JavaScript, especially like comes up a lot more in older JavaScript world. So why is an immediately invoked function? Well, first off, how do we make that? How do we make an IIFE? Well, not too hard. Let's say I write a function called say hello. I think, did I already do that one? Yeah, we'll say, let's call it hello world. Whoops. Okay, and I'm just gonna console log, say hello world. Okay, so I've got this function. Now, I could just call it, right? This is how we've been doing it. But I could also invoke this function at the same time that it's being created. So you do that by wrapping it with parentheses and invoking it. Right, so now if I just run this, it just prints hello world. That question that oh, I'm also printing this. Annoying, sorry. Right, now it just prints hello world. This is an immediately invoked function expression. It's kind of silly that I'm naming this. You wouldn't really need to name an immediately invoked function expression. Instead, I could just run it like this. Right, so this plays a part into closures still. It's all going to work together at the end. I hope you're keeping up. It's all going to just join, hopefully, relatively nice at the end. So, what is a closure? Well, I've actually already showed you a closure today. You might not have been aware of it. Our first example of a closure that we saw was this example. A closure by definition is a function, or yeah, you could say it, think of it as a function that is using a variable that is declared or that exists on its outside scope. So when this, and we can actually look up the definition on MDN. They'll probably have it nice. Closure MDN. Right? MDN is like the place for JavaScript. This is like their JavaScript documentary. So if you ever ask to look something up in an interview, say, you know, ask if you can look it up on MDN. Don't say W3 Schools or something, because MDN shows that you actually know where you should be looking something up. So a closure is a combination of a function bundled together with references to its surrounding state, the lexical environment. In other words, a closure gives you access to outer function scope from an inner function. In JavaScript, closures are created every time a function is created at function creation time. So what does that mean? That means when this function was created, it had access to all variables that were existed out here. Now this was just inside of like the global context scope, but it's still using this name variable. We saw it print Alejo, right? We remember that. Let me just comment this out for a second and go back up to here. What's gonna happen if I change the name? So like what if I call print name here? I change name to Corey, and then I call print name again. What do we think is going to happen? Is it going, and go ahead and let me know in the chat, is it going to print Alejo again? Or is it going to update and now print Corey? Are they both going to print Corey? What's going to happen? How well do we know the nitty-gritty of JavaScript? I love this stuff. Kind of funny that the first thing I showed was a closure, right? We didn't know. Gotcha. We'll go more in depth, though, don't worry. Let's get a few responses in the chat, though. Okay. Amin, Alejo, then Corey. Kong says Corey. So Somebody said duck, duck, goose. No, not yet. No one's written that. We've got no troublemakers in the class. The troublemaker is the teaching one. Well, let's see. Anybody else besides Amin and Khan got any ideas? What do we got? It's gonna do something, right? Douglas says Alejo, Corey, Corey. Okay. Henry says Corey once. Marvin, Corey, Corey. Kevin Brutus, Alejo, Corey. Giovanni, Alejo, Corey. Deja, Corey, Alejo. Interesting. It's gonna go read from bottom to top. Fagan says Alejo, Corey, Corey. Suzette says Alejo, Corey, Rafiq, Corey, Corey. Okay, great. We are all over the map. I absolutely love this. Let's try it. Let's put ourselves out of our misery, and I don't mean killing ourselves. Let's try it, and we see. Oh, we see Hello World didn't save. That was a dark joke. I apologize. Okay, we get Alejo, and then Corey. Interesting. So, well, let's think about this. Let's think about how this works. Well, we've declared a variable. We've called it name. The fact that this says var doesn't matter. Just so you know, right? If it was let var, it doesn't matter at all right now. We have created this function, and this is a closure over the name variable. Now, there's something that you should know about closures, and that's that word I said I was going to keep using, pass by reference, right? Closures are a pass by reference, which means it's going to be keeping track of this variable. It doesn't mean it's passed by value. If it was passed by value, when it was created, this would be Alejo and permanently stay Alejo. But instead, it's passed by value, a reference. It's passed by reference. So it prints name here, and when it calls it, it looks and it says, okay, there's the name variable that I have, and I'm gonna print Alejo. Then we change the name variable to be Corey, and we call print again. Now, print name looks the same, but since it's passed by reference, it's going to look at the variable name instead of look at that original value that it had. Deja, I see you're writing var. Var always gets hoisted. Yeah, but this, I want to just really emphasize, it doesn't matter if this is let. This still works the same. This problem isn't about hoisting. This problem is about we've created a variable inside of the scope, this outer scope of this inner function. And when this inner function is created, it's going to have a reference to all variables that are created on the outer scope of this at time of creation. And so even when we change that value of that variable, our function, so to speak, keeps up with those changes. Okay, I know that's a little confusing, but it's very interesting, if I don't say so myself. Let's go back to another example, something else. Okay, so I'm going to write something. Let's say I create a person object. Let's say, oops, let person. And this is going to go into what Alejo said about closures. We have person. I'm going to write first name. And this is going to be Corey. And I'm going to write a method called getFirstName. And because of the way binding and scope works, which I don't really want to go into on this lesson, I have to write it like this. So I'm going to say function, and I will return this dot first name. Okay, so we have this person. And this person, there, we'll console log person. Okay. I console log it, and we see this is what a person is, right? We have this first name property, and we have this get first name. So this kind of goes into this idea of privacy in JavaScript. There isn't any. Well, you may have heard that. It's not 100% true, but naturally, JavaScript does not have privacy, so to speak. It's not so out of the box. And there's other languages, object-oriented languages, where we can determine what type of methods things are. We can say this method is public, private, We can even say protected. Ruby has all three of those. And whom or whomever is allowed to call those methods depends on whether or not they're public, private, or protected. Now, JavaScript doesn't have that same thing. We can't just say, oh, this is private. We can't just, well, not yet, maybe in the future, but we still can't, as far as I know. We can't just say like, oh, this is, well, actually, this wouldn't be private. Let's say this is private, right? We can't do that. That's not a thing, not yet. So what's bad about this is anybody can go along and I could just say person is dot first name, and then I could just reassign it and I could say like loser, and then I would look at my person and it's been changed to loser, right? So if I had like some kind of script where I'm running on somebody else's site or something like, there's too much exposure, and people can interact or with variables that they shouldn't be able to interact with. Now there's a common practice in JavaScript, right? Maybe you've seen it where we do like an underscore here. So if somebody were to try to do first name and they didn't really know my code, they wouldn't really be able to do it. I guess they would add a new property called loser. But, you know, if they knew that there was an underscore, it doesn't really hide it. That's the point. We say underscore for something that like represents what should be hidden in JavaScript. That's like somewhat standard convention, but it doesn't actually mean that it's hidden or protected. So how could we actually protect this? So let's change this. So instead of writing a person object, let's write a function called person. And let me create a variable. Let's say first name. And I'm going to assign this to be Corey. Right? And this doesn't matter if I'm using var or let. This is just function scoped. I'm going to be mixing both cases. I'm sorry if that's a little weird. And so I could write a function in here. I could make another function that wraps. So like, let's say, what if I wrote a function and I named it get first name, and then I return first name, right? And then my person function, what if this returned get first name, right? This is kind of weird. But if I console log person, now we'll see a couple things. When I console log person, we'll see that person is in fact a function. Okay, that makes sense. We're calling a function right here on line 73. But if I invoke person, this will evaluate to something. And what this will evaluate to is it's going to return another function called get first name. Right. So I've invoked person and I have a get first name. So let me just clean this up a little. So I'll say person is equal to person. So if I wanted to, I could say person and invoke it again, and then I'll get, it's getting a little confusing. Oh, let's call this person, I'm going to call it object, even though it's not an object yet. You'll see in a second. Okay. And we see our Corey. Now there's no other way for me to access this first name. I cannot, outside of this function, change this first name property. This is kind of important, right? Because my person object is this function right now, function called get first name, and this variable, we can invoke it and we can invoke that, but we can't actually do anything. Now, what if I wanted the user to also be able to like set the name, even though I know like I don't really want them touching the properties, right? So let's say I have another function called set first name. and I'll just say first name is equal to, let's pass in a name here, and name. Okay, so now I'm setting a name. So now I can't really just return get first name, right? Because that's just returning a function. So what's something I could return that would allow me to have access to both of these functions? What's something I could do instead?
You can return both of them as an object or array.
Exactly. I love that. Let's stick with object. That's going to be the more common convention, right? So we could return these as an object. So I could say return get first person and set first name. So if I do that, let me just comment this out now. It's not going to work. So now when I look at what we get back when we invoke this person is we get this object with methods associated to it. Now you'll notice we cannot see this variable, right? It exists in there because we can call it. Here, I'll show you that we can call it console.log person object dot get first name, but we can't see it unless, here it is right here. We can't see it unless we specifically interact with this object or the methods in the way we want. This pattern is called the module pattern. This is very famous and popular in JavaScript, right? This is how a lot of your modules that you've imported and things work. This is all those methods that are associated to a module, right? PG promise where you have db.any.none, .one, right? These are all methods on this module class, but we can't see all the other hidden code.
I have a quick question. Oh.
Yeah, Doug. What is it?
Never mind. You kind of cleared it up. So I was thinking that you're creating a new instance of this module class. And then my question was whether or not module was class. Well, you cleared it up.
Yeah, so it's not exactly a class, right? Classes are more about object-oriented programming. This is more functional driven, but this is showing that we have this privacy in JavaScript. And this is important because it allows us to control what our users can and cannot interact with, right? A cleaner way to write this, potentially, is I could say function, let's say first, let's say person, and I could just return right away, and I'd return an object that has like get first name pointing, let me add the name, sorry. I could say that first name equals whatever, right? Maybe I pass this in originally. Initial name, maybe I make it a little bit more interesting than just being hard coded to Corey. Right, and then we will, so get first name, I can just write first name, and then set first name, we can take in a name, and I'll just say first name is equal to name, right? This is the same code, This is the same code, just significantly sexier, right? This is just sleeker and sexier overall, but it's going to work the same. I'll prove it right here. Same. This didn't work. Person.
Because you have the initial name.
Oh, thank you. Right, almost the same code. There we go. Right, so this still works. This is the same, but this is a sexier pattern. So we're gonna try this, right? Because I've been talking for a little while. It's time to switch it up. So here's what I'm tasking you on. I want you. Here we go. This is the task. I want you to. I'm gonna put us in breakout rooms of groups of 3 to 4. And I want you to build a calculator that keeps track of an amount. I should say of, I'm sorry. Of an amount. And you should be able to add, subtract, multiply, or divide, or see that amount. Okay, so you should have to interact with the API that this returns. So I want you to do this with the module pattern. Okay, I'm hosting that. I'm going to put us in, I'm just going to pause the recording before I forget. Let me launch this poll. Tell me, how did it go? How did it go? How did we build our secret sexy calculators, as they say? People say it. Maria says you saw this problem, or you think you saw this problem on Code Wars. Very, very possible.
Yeah, I'm pretty sure I did.
Very cool. Yeah, it's somewhat of a classic. There's the more classical one is to just build a counter, which we can talk about as well.
Corey, what did you? Sorry.
Okay, Alejo first, then Ashia.
I think I saw a similar version also where I had to build a register,
Yes.
like a register from a supermarket.
Interesting. Yeah, I would believe that. Yeah, Ashia.
What did you mean by amount? Like, what was the amount initially?
Like the total on the calculator.
Okay. So then you would have two numbers. Like it would take in, the arguments would take in two numbers, because you wouldn't just put in one number in a calculator. You would put in a number, then put in the operator sign, and then put in a second number, and then get the total.
I think you're taking it a little literal. I'm really wanted it more just like you'd be adding it to whatever that amount is. It's more like along, I think Alejo's idea is better, like kind of like having a cash register or something. So like if a cash register is a fixed amount of like $50 in it at the beginning of the day, and then like certain produce might be worth certain amounts of money, and you would say like, I bought a banana, and then the cash register should go up by so much, but the inventory should go down by so much. That kind of thinking.
Okay.
Okay, I'm going to share the results. So overall, we're living in the 4s and some 2s. This is kind of like, it's kind of an odd shaped. I'm going to wipe out the outliers and then say it's in kind of an inverted bell-shaped curve. I guess the concave curve. Okay, not too bad. Let's go over it. Not too shabby. All right, so for this problem, we're making a calculator of some sort. So let's go ahead and start with a function. I'm going to switch it into ES6 just so people can see different things, right? And so let's call this calculator. And I'm going to start this always at an amount of 0. I don't want to say sum just because we'll be subtracting as well, and I'm too literal. It's not always going to be a sum, right? And so then we can go ahead and return our object. And in our object, we can write our methods and how we want to interact with amount. So we can write a get total, which will just be a function that will have an implicit return, right? I don't need curly brace or anything if it's a one-line implicit. This will just return our amount. Let's go ahead and add a sum. So we're going to say, or an add, sorry. So add should probably take a number, and this should add it to our amount. So I don't want this to have a return value. So I'm going to say amount plus equals num. We'll have our subtract, which will take in a num. Same type of thing, right? I'll say amount minus equals num. And then it's the same thing for multiply. That's times equals. And we'll say divide. Right? So that's all this is. Because these all have access to this calculator's amount. So if we want to if we wanted to test our work here, right, we could say let calc1 equal our calculator, and we'll invoke that. And let's go ahead and look at get total. So console.log, we'll say calc1.get total. Right, but now if somebody just wants to change the total to like 50, like they can't. There's no way for them to do that without interacting with our methods that we've prescribed. So we can say calc1, dot add, and we'll just pass in a 5. So now we should have 5. Let's try a multiply in here. Multiply by 5, so now we should have 25. Let's get our total. Whoops. Let's try a minus in here, or a subtract. Let's subtract 2. Console.log calc1 dot. Whoops. If only I didn't have such fat hands. My mother tells me my hands are fat. No, she doesn't really. Minus 2, we should get 23, which is Michael Jordan's number, which was the point of this. Okay, so let's take a look. And we get some other old crap that we printed out, but we see our total starts at 0. We have 25, which was the next time we called it. And then we have 23. Right, I could make a second calculator, right? This is, let me just comment these things out. I don't want these. All right, if I made a second calculator, it's important to note that this will have its own amount that's being passed by reference. They're not looking at the same amount, right? So if I call at the end here, get total on calc2, right, it should be unchanged. It should still say 0, and it does, right? So that's kind of important, is like these are not connected to all instances. It's just all of these methods have access to their variable that's made. But every time I run this function, there's a new or another version of this variable that exists for the next versions of these, so to speak. Any questions on this calculator? Okay, so just to reiterate, this is the module pattern. This is a common programming pattern, and this is like, hopefully you're starting to see and kind of understand why, or like how this helps with like security or privacy, so to speak. Right, this is a private method. Now, if I wanted this calculator, right, I don't actually have to name this. Like, let's pretend I just wanted to rip all this code, right? I could have done something like this. And this is where, like, if I just wanted to have a calculator, like I'm going to call this let supercalc, and I had all this code, right? Maybe I'll make it a constant. I could wrap this. This kind of goes back to earlier. I can wrap this in parentheses and invoke it. Right? So now I'm making an immediately invoked function expression. Why would I want to do this? I don't know, but there could be situations. Just take my word for it, right? There could be a time, right? And so in doing so, I have this supercalc, right, which isn't a function, and this only exists in this exact moment in time. Right, and it has access to this. There's one version of supercalc, and everything in it refers to this amount variable, right? So I've created this without actually exposing this amount anywhere. So this is another thing to think about. Now, outside of the module pattern, I want to talk about the other thing that everyone said when I mentioned closures, which was like, hey, it's a function that just returns another function. And it's like, yeah, that's kind of true, right? So like, let's say I had a counter. So I want to make a counter function, right? And this is also a common kind of interview question. And this could have a count, and I'll set it to 0. And this could just return And I could call this a function, right? Like I could say a function increment, right? I could just return right here and return count, right? This is going to increment my count at the before it actually shows the word count. I would argue, although this may be more clear, sort of, I could also say like, we don't really need this to be named because we can't call increment ever in this scenario, right? Like here, I'll say let counter 1 is equal to counter, and I invoke it. If I console log counter 1, we're just going to see that it's a function called increment, but it's not a method or something. I don't have an increment method, right? I can't say dot increment. That doesn't do anything. You'll see, well, we'll throw an error. It says increment is not a function. But that's because I'm not actually returning an object. Counter 1 right here is a function. Does that make sense to everybody? It's kind of an important point. Give me a yes or a no in the nonverbal feedback feature. You can also talk, but. Okay, some no's, mostly yeses. Okay. Okay. So just to repeat this again. So like, right, a function is, like an invoked function is whatever it evaluates to, right? An invoked function is whatever it evaluates to. So if I have a function that's called const and I say return 2, and this is a function that just returns 2, right? Anytime I write return 2, that's the same thing as writing the number 2. Right? Because it is what it evaluates to. Now, obviously, I wouldn't write a function that just returned 2. That'd be ridiculous. But it's the idea that it is what it evaluates to. So this counter function is what it evaluates to. And that is it evaluates to a function, to this, right? This is just a defined function. This isn't an invoked function. So if I invoke counter, I end up with this defined function, which is specifically called increment in this case. I can't call it like this because this is calling a method, which means I'd have to be calling this on like an object. Instead, counter 1 itself is the function. So I would just invoke counter 1 if I wanted this to increment. So I could write 1, right? And then I could write it a couple times if I wanted to keep incrementing. 1, 2, 3. And that's why I don't really need the word increment here. It doesn't do anything. So I could just write an anonymous function. Same thing. Maybe I don't really like ES5, so I want to go back to ES6 and just return this, right? This is the same thing still, just cleaner and easier to read. Right, so we can have a function that returns a function. Now, the cool thing is this function has access, right, to the variables that were declared before this. Same with if I pass something in, like a number. So I'm going to write a function called adder, and then you're going to write a different function. So let's say I write a function called adder. Okay, and this is just going to take in a number. I'm going to say A, and I'm going to return another function that's going to take in the value B, and this is just going to return A plus B. Right? So this function has access to all variables that are on the outside of its scope. Right? So it still has access to A because A is being declared here, right? Which is still within this scope. So adder doesn't have access to B, but our inside function here has access to the outside functions of A. So what's that mean? I could make a bunch of functions really quick. So if I wanted a function that adds 5 to everything, a function that adds 20 to everything, all I have to do is say const add 5, right? And I can just call adder and pass in the 5. So this returns a function, right? If I look at add 5 right now, if we look at add 5 is a function, right? It's an anonymous function, but add 5 is a function that is going to add the number 5 to whatever number I pass it, right? So I could also make a function called const add 100. I don't like that, 100. And that's going to call adder, right? I'm going to use adder here too, but this one's going to add 100 to whatever I pass in. So now I could say add 5 of 5. And let's say I want to add 100 to 5. So we'll see 10 and then 105. Let's see. And we get both, right? So this is a way to, this is almost kind of an efficient way to make like multiple functions that have some like overlapping information, essentially. We're able to have a function that has access to that. Any questions on this?
Corey, for like adder, you're only passing in A, so how does it know? I guess I'm confused about the B variable. 160.
Cool. Right. Okay. So right, this is really what we're going for here. So you're right. Adder only takes in the variable A. So adder took in 5 here, and adder took in 100. Now, adder actually returns a function, right? It doesn't return like a traditional value. It's returning this whole function. Okay. So we can save that function, which we're doing on lines 164 and 165. We're saving that function as their own variables. Also, you could think of them as kind of functions, right? So we're creating this add 5 function right now by calling adder and passing in this 5 value. So this gets stored in this value. This is part of like closures. So this function here, when it was created, it's going to save the value of A. So this still will have access to the original A, even though adder's already finished running. Even though adder's done, this new secret function, so to speak, the inside function, still has access to that original function's values or variables. So this is now a function that essentially says B, takes in B and returns 5 plus B. This one's the same thing, instead it's 100 plus B. And so then we can call these new functions, add 5, that takes in a 5, and add 100, that I'm also having it take in a 5. And we see that this will give us back our 10, because it's still hanging on to the original A of each of these.
Okay, cool. That makes sense. All right.
Awesome. So this is a question I was kind of asked. I mean, I was asked a similar question, right? Also, I could do, if I wanted to, I could say console log. And if I just wanted to add 2 numbers together, also fairly simple, I could say adder, and I could just add, let's say I want to add 5 plus 18, right? And then I'll get Michael Jordan, 23, right? So this is valid JavaScript. This may look kind of funny, but it's okay, right? This is a function called adder that takes in 1 argument. This gets invoked and returns 1 function. This function then is getting invoked and being passed its argument of 18. So your task, which was also a question I once was asked in an interview, and I butchered it at the time, but you're going to do better than me, which was write a function that, write a function called greeting that looks like this. I think it was something like this. Greeting, hello world. and returns hello world. Something like that. Okay? This is your next task. This
So-
is your next challenge.
So when you say looks like this, it's the call, how you call it, right?
This is how I want to call this function, so to speak. Yeah. Okay? And we will go back into breakout rooms. I think we're only going to need 10 minutes for this one. Let me just pause. Welcome back. Welcome back. Hello, hello, hello. Wow. How we doing?
Good.
Good. Good. We are doing fine. We went there, we destroyed the greeting problem.
Oh, Corey, you were talking about Michael Jordan so much. I was gonna say, if you have on Netflix, The Last Dance is up. I don't know if you've been watching it.
I know. I got to watch it.
Oh.
That's why Michael Jordan's on the brain. I haven't started yet, but my father told me it was great.
It's great. I'm like almost done with it. It's such a good documentary.
Oh, don't spoil anything about it. Joke, because obviously it's Michael Jordan. Already happened.
Exactly.
Thank you for that delayed laughter. How did we do on this? Scale of 1 to 5. Oh my God, is Owen Wilson here? Yeah. Wow. Thanks, Sam. What a great humorer. Thank you for humoring. Okay, we got 16 out of 24 votes, 17 out of 24 votes. Can we make it 19? 19, can we got 20? We got 20, 19, 19. What do we got? 20. We got 20 going once, going twice. Can we get 20? Sold for 19. The rest of you too slow to tell me how. Oh, we got 20. Nice. Okay, you squeaked in. All right. Let's share the results. We are in the 3 world, right? So tell me about it. What did we find challenging? What did we find easy? What were we thinking? What were we thinking?
I think the way the call was set up, like having the 2 different variables and how to kind of show that in the function, but I think we were able to get through it.
Cool. Okay. Yeah. Just so the fact that it looked different than what we're familiar with, right? That's mostly what you're getting at, right, Ashia?
Yeah.
Yeah, right. It looks funny. Whoa. Ouch. Okay, so let's do it. Let's write it. Unless anyone else has anything else they want to say about it. Let's say greeting. This is a function that's going to take in a word. So let's say first word. And this is going to return a function that's taking in a second word, right? And all that this is doing is it's creating our sentence. So this is just going to return our first word. I can use string interpolation for this. So we can say first word, second word, and exclamation point, right? And so this is really all that it is, right? This problem is kind of like a tricky one because it's the exact same problem we wrote with adder, just disguised a little different, right? So if I console log, I can say greeting, and I can pass in hello, and I can invoke the function that this returns and pass in world, and we should see hello world shouted out. It's a wonderful greeting. Hello world, right? This is exactly what we were going for. So because we have this example here, I am going to show the sexier version of this because I think that's important. Right? It's one of the cool things about ES6 and ES5 is we have these implicit returns with arrows, right? I'll remind you, an implicit return is when we don't explicitly have to say return this. Instead, we can put parentheses after the arrow and it will immediately return whatever is inside of those parentheses. Or we can just forego parentheses entirely You would need them obviously if you wanted to return like an actual object, because then otherwise your object would be interpreted as your function. But if not, we can actually just forego these parentheses and just do an implicit return. Same with these parentheses, right? I can just implicitly return that as well. And this is the same thing as before. And we technically, since we only have one argument, we don't even need to pass in these parentheses either, right? And this is the exact same thing, just one line and really beautiful looking. I mean, wouldn't you want to take that out to dinner, right? That is a gorgeous looking function. So this is something that's kind of cool. So what do you think would happen if I wrote like this, like const, what if I tried to invoke a function like this? Make sentence, and I said, what is even happening? How could I make this valid code? Yeah, I mean, I saw you flick off on mute real quick. What do you think?
Yeah, you probably do like 4 returns inside.
Yeah, right. This is the same thing. So this is something that eventually kind of comes with later on. You might want to learn about currying, but right, we could like make a function called make sentence. And all this does is take in first word, second word, right? Third word, fourth word, and then returns them all together, right? We could just, I guess I'll do it like this again and just say first word, misspelled. Ugh, this is going to get annoying fast. Should have just done 3. Oh, well. Second word, third word, fourth word, right? And that's, and so now we actually have this valid JavaScript, even though it looks kind of funny. Can anyone think of a real example that we've already used that involves closures? I think 6.2 probably covered this too, but for sure 6.4. So anybody think of code we've already written multiple times actually that involve a closure? Hint, think about some Redux patterns.
Reducers?
What is it?
Reducers?
Not quite. So reduce is just a pure function. It returns the next state. It can't actually return a function, but we do use a piece of middleware to
right?
things like that. What's that, Danny?
Oh, is it async thunk?
Yeah. Is that Marvin? Who is that?
Yeah,
Okay, yeah.
Cool.
Yeah. For a second, you talked like Danny. That was interesting. You have to show me how to do that later. I've been meaning to prank call people that Danny knows. Ask Danny. Yeah, right. Kind of like create async think. What I'm thinking about specifically is our asynchronous action creators. So like if we go, let's see, where would I have covered that? Probably React Redux fruit stand. Or no, it would have been some, I'm trying to find a like actual code that we would have done this. Did we use asynchronous action creators in any of these?
I think it was fruit stand, but it was a later fruit stand with Redux.
What?
I think it was the action, the extra reducers, right?
Yeah, maybe it was in, yeah, maybe it was when we were doing Redux Toolkit Continued.
Yeah.
I think that would be it. And we go into our features, right? And we had posts, excellent. And we had our post slice, right? What does this look like? Right? This is that, right? This is a function called fetch all posts that returns a function that takes in the arguments of dispatch or get state and then we can write asynchronous code that and dispatch those other actions to our reducers, right? So I know this really won't make as much sense as 6.2 because they didn't do this example with me, and it's been a while for 6.4 as well. It's been like a couple months, so I understand if we don't totally remember this, right? But like I think we had to create a post somewhere. Maybe we didn't do that example, but right, it's the same kind of idea. It's our middleware is intercepting to see whether or not this is a function. That was thunk middleware. It goes, oh, is this a plain JavaScript object action that needs to get sent towards the reducer? Or is this a function that I need to invoke and fire with the arguments dispatch and get state, right? And that's the whole thing that thunk middleware does. And so this is a real life example of where we're seeing some of these. This, if I were to pass something in here, right, inside of here, we still have access to whatever I passed in.
Another example that I just thought about, and it's funny that it's also middleware, is an express. The middleware where we do like express.json or the cookie parser. Those we invoke and pass on to app.use, which then means that whenever we invoke them, those return a function as well.
Yep, that's right. Yeah, let's go to, that's a great point, Aleo. If I can go to our backend somewhere, where would we have done backend? Is there a full project?
Unit 3, I think backend is Unit 3.
To do walkthrough, I would have done a full app, I think. Oh no, maybe I just kept it on the front end. Okay, we can go to Unit 3. And we'll say PG promise intro maybe. So in our app.js, right, we have express, which we're requiring is this module, and then we can call methods on express, right? We invoke this. This is returning a function that we're invoking. But another good example that I wanted is to show right here, our PGP, right? This is a function, right, that gets returned. We send in our optional options argument, but then we're calling PGP immediately, passing in like whatever the name of our Postgres URL, our database URL is, right? This is the same thing as if I would have written it here, right? And then just not had that, right? It's the same thing. So like these do exist all over the place. You just have to kind of look for them. Hopefully they'll feel so, or look so natural, they won't look out of place. So I know I said we were only going to 4. We are going just a little bit later. I apologize. Because there's one more thing we haven't addressed, but I haven't forgot, and that was this sucker. Printify. Okay, so I'm going to give you 2 options, and I want you to vote with the poll. So option 1 is we go into breakout rooms for 10 minutes and try to figure this out on our own. Option 2 is I just go over it with you all. Okay, so let's relaunch the poll. 1 is you want some time in a breakout room to work on this. Option 2 is I'll just go over it and then we'll be finished with everything a little faster. Okay. And I'll just go with whatever the majority says. Okay, majority's in. No need to vote anymore. Share results. We are going to go into option 2, so this will be a little bit more brief. Okay. So how would we make this work? How do we put all of this together? This is kind of like the wild. the Wild West ending here, right? We know about immediately invoked function expressions. We know about closures and how we can keep variables stored. So how can we do this? How can we actually successfully print 5? Let me make sure I'm not console logging anything else. Okay. I'm just going to rip all this, take it down to the bottom again, so that I don't have to keep worrying about scrolling. Okay, so, well, it's not so crazy. Instead of calling the set timeout here, we can actually make an anonymous function right here. And we can do similar to what Amin was saying of creating another variable, right? So I could say like var variable to print, right? Remember, var is function scope. Right now, this is in a function. And then I could move all this code, our set timeout, inside. And instead of console logging I here, I'm going to console log variable to print. Now I'm going to need to invoke this function. I didn't mean for that weird space there. Okay. And now if we go to print 5 with var, we should get 1, 2, 3, 4, right? So this is how we can do this, by creating another variable inside of another function, which will have access to the I still, but this function will only have access, will be the only one to have access to variable to print. And so with each iteration, a new function will be firing, and therefore it will be referencing its own variable to print version, and we can be console logging that. Now to make it a little prettier, because I know we're all obsessed with pretty code, right? I don't really need to do this because this is a little awkward looking. Instead, this anonymous function that I had to write, we can instead pass an argument into it, like, I don't know, variable to print. And then when we invoke this, we can just pass in the argument, which in that case is I. And this will also work. Magic. Magique, as someone might say. Someone with, I don't know what accent that would be, but that's a cool accent. Magique. Any questions on this?
So the way in which the variable to print, or in this case, is capture, like I, is because we're creating a brand new function on each iteration. And that's what captures I sort of inside.
That is correct. And we invoke this function immediately. So it's,
I see.
It's not being saved or anything. But this is the way they would have to used to do it before having let. Let really makes it a lot. Let kind of ruins the question. But you could be asked something like this in an interview. Like, specifically, like, why does this print 4444? Right? Because you can't just say, well, if you change it to let, it doesn't. It's like, okay, yeah, great, but why? Right? The why is what's really important, because the why is what tells us, like, really shows our understanding of how something is working and happening. So the why here is that it's all about scope. When we had var, it hoists this up because var is function scope. So there is no such thing as block scoping in ES5. So in doing so, we're creating a new function that we can then therefore have a new scope and immediately invoking that. And so that this variable will only refer to the variable that's being passed in, which we're passing in I when we invoke this function. Okay, any other questions? Okay, cool. So I will post all these notes.
Corey, I have one last question.
Yes.
Would this still work if we get rid of variable to print and just console log I in line 186?
No. So I don't believe so, because I is still going to be referencing this I, which isn't actually block scope. So you can think of it as this if it's easier to think of it. If that helps, right? Because this I is still going to be referring to this outermost I.
Got it. So we need to create an inner variable or pass it as an argument to capture it.
That's
Way.
correct.
Got it. Thank you.
Because we need to create that new scope for it to refer to. Pretty interesting problem. I think. I hope you enjoyed it. I'll stick around for questions. I don't want to make everybody stay. I'm going to end the recording. But yeah, I don't